If researchers don't really find the right samples, the study stalls. Collaboration wasn't limited by geography. It was honestly just limited by visibility and connection. Science only achieves its purpose when it's shared and understood and it's applied beyond the labs.
Welcome to the Imprint Hub, where we talk about maternal and pediatric pharmacology. Today, we are talking with Dr. Chris Phillip. Welcome, Dr. Phillip. Thank you so much for joining us today.
Hi, Emily. Always a pleasure.
Can you start by explaining what copper is and what gap it's designed to fill in the maternal and pediatric research field?
So, Copper is this platform, and it's called the Collaborative Online Perinatal and Pediatric Repository. It's basically, or at least what we're trying to build, is a global directory that connects researchers to biobanks focused on maternal and child health. And it was basically designed to solve a long-standing challenge in our field, which is researchers know that valuable specimens exist. It's just that they're scattered all across different institutions and they're hard to locate. And so historically, people have relied on word of mouth or informal contacts just to find some samples. And that can take months and sometimes even years. And so Copper changes that by bringing all of this information into one searchable platform. And it shows, what's available where and under what conditions. And yeah, so this basically transforms all these disconnected collections into a coordinated resource, which saves time, it avoids confusion, and it also fosters a lot of collaboration. And our ultimate goal is obviously to accelerate the discoveries in maternal and pediatric medicine.
So what kinds of things can you find in copper? Like what types of biosamples could somebody be looking for where this would be useful?
Right. So at the moment, we've got maternal blood, so plasma and serum. We've got cord blood, placenta, breast milk, urine, saliva, and we've got some pediatric samples as well. And so what makes it more valuable is not that it's just this collection of biosamples or biobanks that have these biosamples. It's just you've got a very detailed metadata like gestational age and the collection time, the storage process, the diagnosis, the study design. So you can actually go to the website and sort of do a search in a very meaningful way. And for example, if a researcher is looking for something very specific, they can just go into the website, check, put in their inclusion criteria, look for exactly what they're looking for, put in their criteria. And then you've got this system that just churns out all these biobanks that have these specimens that are available. And so basically, what used to be months of outreach, it can just be, you know, shortened into a very few clicks.
So a lot of times when we think about people doing this type of research, for example, in early pregnancy preeclampsia, we
Mhm.
think about them, filling out the IRB form, collecting their own biosamples, doing the research throughout the entire process. So what's the benefit of using something like copper, working with other biobanks that already have existing biospecimens rather than going through the whole process from start to finish?
Right. So, rare conditions like early onset preeclampsia can't be studied adequately at a single site because the case numbers are really, really small. So when you have multiple repositories to pull, those small numbers start to add up, and then it allows for much meaningful analysis.
So, speaking of preeclampsia, you recently led a feasibility study using copper to identify those early specimens.
Mhm.
Can you talk a little bit about how your study worked and what you learned from it?
Right. So the main motivation behind that was just this that it's always scarce and that we just wanted to see what copper was doing. We just wanted to see if we could not only identify early gestational samples but also to sort of see if copper actually helps with it. So this was more a feasibility study. What we did was at that point we had about 17 biobanks and now we've got about 20. And so we reached out to these 17 registered biobanks and we asked them if they had the plasma or serum collected before 16 weeks, gestation for in a pregnancy that later went on to develop early onset preeclampsia. So instead of requesting the participant level data, we only wanted the aggregate counts just to see if I were a researcher basically and I wanted 100 samples, is this a sort of a feasible place that we can kind of get the 100 samples. We were very impressed by how all of it worked. The coordinators replied almost instantly. I mean, right off the bat, we had a few, like I think 5 or 7 biobanks that just could not participate because they had very different samples that we were looking for. They had either, breast milk, a placenta, and things, which were not what we were looking for. But then the others who had eligible samples, biospecimens reached out to us and told them, right, this is what we have, this is how we collected it, this is how it's stored, these are the numbers basically. And so when you aggregated all of those numbers from about 17 biobanks, which kind of dwindled down to 7 eligible ones, we had 115 samples. So, if we wanted only 100, we had access to like 7 different biobanks that we could have reached out to and said, hey, can we have whatever you have, and then just add that, and that added up to 100. So basically, it just showed that collaboration wasn't limited by geography. It was honestly just limited by visibility and connection. So when those barriers fell, we feel like the research might actually move a lot faster.
So you feel like the feasibility study basically said that, yes, this is incredibly feasible,
It
that
is.
and that basically multi-repository research is
Mhm.
doable.
It is. It is. It's very doable because it's cutting short your time by just months, weeks, months. The researchers don't have to spend so much time and effort finding another coordinator, trying to coordinate this one. You can just do it yourself. A simple email, which is all in on the website, you just reach out to them directly and you get all the information you want. So it's pretty brilliant.
That is fantastic.
Yeah.
So looking ahead, what is your vision for copper and the future for what you think copper is going to look like?
We're hoping that copper and the imprint network will grow into truly, interconnected ecosystem where it makes the maternal and pediatric research come about a lot faster, smarter, and be a lot more inclusive. So I see a future where the data standards are harmonized, collaborations are seamless, and then discoveries to immediately translated into better care. So I do feel like copper serves as a bridge between institutions and between researchers and clinicians. I think we can build a patient-centered infrastructure that just doesn't store information, but that it also transforms to impact.
So let's talk a little bit about how we move this type of research into a clinical setting. So
Mhm.
it's sometimes when we talk about research, it can seem very separate from actually how patients get treated and how this impacts clinical practice.
Mhm.
Can you talk a little bit about how you see this type of research improving clinical practice?
Oftentimes, I think access is really the starting point of every discovery. And if researchers don't really find the right samples, the study stalls. So, I feel like something like copper eliminates that bottleneck of letting investigators identify and connect with the right biobank instantly. And so that I think itself accelerates and validates replication in every diverse study population. So when the process of finding the materials become easier, I think the pace of research naturally increases. And that means more diagnostic tools and treatments that reach patients faster. And so it's about basically turning years of groundwork into months of progress.
I've always thought very highly of Katrina Waite has said something to the effect of like it is up to researchers to make the most of the biosamples that we get from our patients, their contribution, whether that's in their time, through their samples, through their, the information that they fill out, that it's really incumbent on us to
Mhm,
absolutely make the most of it.
mhm.
Do you have any thoughts on how something like copper can really help researchers encourage patients that to make them feel more confident that we as researchers are making the
We're doing
most of
this. Yeah.
this?
Yeah. I found recently I was having this conversation with one of my PIs, and they were talking about how when at least when we go to recruit patients, you tell them, all right, this is what we're looking at, this is what we're hoping to find, or maybe we don't know what we're going to find, but these papers will be out 2 years, 3 years from now. And when they come out, it's like, please go ahead and read. But a lot of this medical jargon is just going to go really way above your head. But every time we do go to recruit patients, I feel like spending a little bit of time with them to explain the importance of what they're doing, because honestly, none of this is going to be possible without the patients and their participation, right? And, a lot of women's health, a lot of research is just lost on pregnant women, children, women in general, but, mostly pregnant women. But so when you emphasize that, right, what you're doing is important, and then sometimes I show previous studies and their results, and again, I break it down into plain language and say, this is why we do certain things the way we do it. And that helps because they feel a little bit more involved and they feel like they're contributing to something much greater. Transparency is another thing that I think matters a lot. When you show patients how their participation potentially contributes to progress, or when people understand the value of research, I think they become a bit more engaged, and more trusting. So ultimately, I think science only achieves its purpose when it's shared and understood and it's applied beyond the lab.
Thank you so much for joining us, Dr. Phillip, and I look forward to meeting with you next time.
Thank you so much for having me.